A function is a mini program or a block of code that performs an action. A function only works when you call on it. For example, if we want to find out how many elements are in a list of grades, then we can use the len function. This is a built-in function, and we don't really see the code that is used to make this function work. And this is because someone already developed that block of code containing the algorithm that counts and displays the number of elements in an iterable. And then it was made available for everyone to use. So the len function has one parameter in which an argument will be assigned to it. That argument could be any sort of sequence. You'll need to get familiar with Python documentation so you have a better understanding of what kind of arguments could be passed into these functions. A parameter is a variable within a function that is used to store information. That information being stored in a parameter is called an argument. In other words, an argument is information passed into a function. So for example, the print function contains different parameters. You can find those parameters using the Python documentation features such as the help function or use the question mark after the word print. According to the docstring, which is just another word for the documentation of that function, it shows that the print function contains some parameters such as value, SAP for separate, end for end of line, and some others. These are considered to be parameters within a function. The sep and the end parameters have default arguments assigned to them, which could be modified. Looking at the documentation for the range function, there are different ways that this function can work. The range function can include one argument, or it could include multiple arguments. Taking a look at the Python documentation, the second line where it has range and has multiple parameters, start, stop, and step. Step happens to be within bracket notations, meaning that this is an optional type of parameter that does not need to be mentioned when trying to use the function. To put this into context, the order of the argument values inside the function's parentheses will determine how the function will behave. The first range function will generate a list of numbers depending on the arguments entered in the function. If we were interested in a function of numbers between 0 and 9, then we would enter the number 10 as an argument. The range function will produce a list of 10 elements where the sequence starts at 0 by default and then end at the number 9. Alternatively, the range function allows for multiple arguments as shown here with my_range2, where the range function with the values 5 and 10 is separated by a comma. This means two arguments are passed into the function. Now, the value 5 is the starting point for the range and the value 10 is the ending point. But the value of 10 will not be included since it's considered to be an exclusive argument, meaning it's not going to be part of the range sequence. If you want to display the entire sequence of a range function, then you could apply the list function as shown here. Here are a few examples of how the range function works based on the Python documentation. Example 1 has one argument passed into the range function, while the second and third examples increase the number of arguments. The output for each example is displayed under line 3. Technically, these statements you see in lines 1, 2, and 3 involve 3 functions each: the print function, the list function, as well as the range function. Each function has at least one argument being passed in. Example 3 shows the range with the step parameter. The output is shown to be every other number in the sequence because the step is equal to 2. A range is considered to be a sequence, also known as an iterable object, so it could be used in repetition statements such as a for loop. Here's an example of the range function and the len function being used together. The number of elements on the grades list will be used as the range. The len function is the only argument inside the range function, so the range will start at 0. Here's an example of a for statement where the header is using the range function, and within the range function, the stop parameter contains the len function on grades. The len function returns an integer value that represents the number of elements in a list variable, which will be used as the argument. The sequence generated by the range function could be used as an index to that grades list. The for clause suite contains 2 arguments that displays each index as well as the element inside the grades list. Here's another function called enumerate, where its purpose is to add a counter for an iterable object like a list. It's similar to the range function, but it does not have a parameter called step. You see from the output here that it produces a bunch of tuples. Since enumerate is included in the for statement header, and its argument is the grades list, the element now has a number mapped to it, which is a counter. The first value of the tuple is the index from the enumerate function, and is followed by a second value, which is an element coming from the list. Here's another example of a similar for statement, but the header of this for statement on the right contains a starting point argument. In this example, the for clause contains a header with 2 arbitrary variables, one for the enumerate counter and the other one for the element in the list. The suite of this for clause, which begins in line 7, uses dictionary indexing to update the grades dictionary variable that is initialized in line 4. The print statement should not be indented, but it was intentionally positioned to illustrate the iteration as each new key value pair is added into the grades dictionary. The input function is typically used to prompt users for information in a program. This input allows for one line of information and it reads as a string type. The type conversion functions such as float and int can be used depending on what needs to be done with the input provided. In this example, the block of code in lines 1, 2, and 3 is a program that prompts the user for an ID number, then displays the information entered as well as the data type of that variable, which is a string. The type conversion functions such as float and int can be used depending on what needs to be done with the input provided. In this example, the program will prompt the user to enter a number value and add 100 to it. The input function in line 2 has a float conversion function since the number entered by the user needs to be converted from a string to a float. Again, anything coming from an input function will be a string value by default. So this is why there needs to be that conversion function. The bottom example is doing the same exact thing, but the calculation is performed right before the input value is stored in the num variable. This should give you an idea of the flexibility when it comes down to coding. Okay, so now we're familiar with what built-in functions are. It is possible to build your own function in Python and make use of it as part of your program. This is called user-defined functions. Like a built-in function, you can use it anytime without having to rewrite the algorithm in a different programming script. This saves time and minimizes any sort of duplicate coding. To build your own function, the header of the code begins with the diff keyword, followed by the name of the function you would like to give it. This name will be used in your program when you want to call that function so it can process the block of code under the def statement header. The name of the function is followed by a set of parentheses and then lastly, a colon symbol. Just like the control statements, once you press enter on that header, the next line of code will be indented. This is the body of the function that will contain the action code. Each line of code must be indented so that the program knows it's part of the user-defined function. But first, let's take a look at some user-defined functions without a parameter. So user-defined functions have different formats. Here's an example of a function that is prompting the user to enter their username information, and then it's going to display a greeting message. Running this code will not output any information until the function is called to use. After defining the function, you can now call it into your program. To call it into your program, you will enter the name of the function followed by a set of parentheses. When the function is called on, it will then execute the block of code that's within the DEF statement. In Python, a variable inside a function is called a local variable, meaning that this variable can only be used within the defined function and cannot be referenced outside of its block of code. We call this local scope. Variables defined outside the function have global scope, meaning that those are variables that can be used in or outside the user-defined function. The bottom code example, line 3, is the variable my_var, which is defined only within the function. This variable will accept information by the user once that function is called on. This variable has local scope, and the username information cannot be referenced outside of this block of code if it is needed later in the program. But there is a way to change that, which we'll discuss next. Take a look at this code. It makes use of the Python keyword global, which is then followed by the name of the variable inside the function. This makes the variable inside the function a global variable, which can now be referenced outside of the function's block of code. So with this example, the username input can be referenced outside the function's block of code, and you'll see this where the print statement is in line 9. If that global keyword was not in line 3, then the program will shoot out an error. There could be variables defined outside of the function's block of code that are considered to be global without having to use the global keyword as shown here in this example. This can be used anywhere in your program. Line 2 has the variable defined that is later referenced in the user-defined function. Now that's a little bit different from the first example shown earlier that's now shown here on the bottom. So one may ask, why not just make all the variables in your program global? Well, for one, that is not good practice, and things will become very confusing as more code is built into your program. There is a term called spaghetti code, and you can read more about that through an internet search. When defining a function that requires an argument, the DEF header or the def header must contain a parameter. The difference between a parameter and an argument is a little confusing, but think of a parameter as a container or a variable in which the argument will be stored to. This example is a user-defined function with one parameter, which is also labeled parameter for demonstration purposes, but this could be any sort of label name. This parameter will be referenced within the block of code underneath the def header. This example shows that the function's parameter is squared by using double asterisks followed by the number 2. The result of this expression will be stored in my_var, which will then be displayed. When the function is called, the argument inside the squared function is 4, and then the program displays the squared result of 16. A function contains an optional return statement in its block of code. This statement may contain an expression or a result from an expression that is being evaluated. So adding on to the previous example, the second code towards the right contains a return statement, which is a keyword in Python, instead of using a print statement like the one on the left. The code on the right also has a different label for the parameter. The function's body contains an expression that squares a number that will be entered when the function is called. The return statement contains my_var, which is a result of the squared expression. And then finally, in this next example, is just a different way of writing the same code as the portion in the middle. But now the return statement contains the expression without the need of having a variable my_var. I will note that using the print function to display the result is not the same thing as using a return statement. In general, the return statement allows what's being returned to be referenced later in your program. Here's an example of two user-defined functions. The one on the left is limited to only 2 arguments when the function is being called on, and the one on the right is an unlimited number of arguments when the function is being called on. Both functions have the name addMe, and the purpose is to add whatever type of arguments that are being passed into that function. Now, on the right-hand side, line 1 has an asterisk preceding the parameter name. And this is an arbitrary argument, meaning that if you do not know the number of arguments needed to be passed into the function, by putting that asterisk preceding that parameter, then it could allow for an infinite number of arguments. So you'll notice in line 7, we have 3 arguments being passed into the addMe function, whereas in line 4 on the left-hand side, it's only limited to 2 because in the header of that definition statement, there's only 2 parameters, not using the arbitrary argument style. When using arbitrary arguments, the arguments that are going to be passed into the function will be stored in as a tuple data type. You can incorporate keyword arguments through user-defined functions like shown here. The student function contains the keyword arguments parameter. The abbreviation name keywords is arbitrary, so it could be any name as long as 2 asterisks precede it. Keep in mind that a lot of Python's documentation uses this label as a standard. The body of this function contains a for statement where the header contains the .items method because keywords is considered to be a dictionary data type. Inside the suite of the for statement is a print function that's used to print out the elements inside the keywords dictionary. When the student function is called, it accepts the format as shown in the parentheses. So there's a keyword, then an equal sign, then a value. There is no limit to the number of keyword arguments that can be passed into the student function. Keep in mind that the keyword format only accepts alphanumeric characters, but must begin with a letter. Now that you're familiar with built-in functions and user-defined functions, let's talk about methods. Methods are actually functions, but they're called methods because of their use for specific data types. Methods are entered by referencing the object or the variable followed by a dot, a period, right? Then a method which is going to end with a set of parentheses. For example, the .lower or .upper method is a function specific to string data types. A variable containing a string can use these methods, but a variable containing a tuple cannot. Now with functions, functions are called without an object or a variable that's attached to it or before it. So for example, there is a function called sorted, not to be confused with .sort, that's specific to a list data type. However, since sorted is a function and it's flexible to other data types, it could be used on a list.